So today's lecture is going to be on graphing a line, linear equations. So I'd like to start with the standard form of a line, which is ax plus by equals c. So standard form of a line, we have, what makes a line, by the way, is that there is an x and there is a y. This a, b, and c that you see in this formula, let's see, can you all see that okay? Let me turn it over just a little bit. Okay, so A, B, and C stand for just any real number in this. What makes it a line is the variables, the x and the y, which I know these are letters too, but A, B, and C in this formula stand for numbers. So some examples would be like 2x and a 3 in front of the y. 3y equals a constant 5. I know that graphs to be a line. 5x minus 2y is 6, another example. So various A, B, and C values, but what's making it a line is x is raised to the first power, which we don't really see that, but it's understood to be raised to the first if there's no other exponent. So x being to the first, y being to the first, we can have confidence when we graph this that it's always going to be a straight line. Regular, just 1x and 1y equals a constant 10, for example. That's going to graph to be a line. Sometimes they mix up the order, which we can do that, and it's equivalent. So this would also be an equation of a line. We have a y to the first, and this -1, then x to the first, and then 3 is a constant. 2y, here's another one that has the y on the left side and the x is on the right side. So it's not in standard form, but again, it is a line. I know that if I graph a couple of points, I can connect my dots. It's straight every time. Sometimes the x or the y is missing. So another example would be just simply y equals 5. It could be a special case of a line. We'll talk about that is just a horizontal line whenever it's only one variable. Or just x equals a constant, like x equals 3 is a vertical line through 3. So because one of these variables could have a coefficient of 0 in front of them, so that would count as being a number, you know, and then it would x out one of those terms and leave a special case. Another thing that could happen is you could have 0 on the end, like x plus y equals 0 is your constant. So that would be another example of line. So all of these are lines, and if we use some of our graphing methods, we'll be able to show the picture of that, the graph of that. So we have 3 basic methods for graphing a line, and you pick the one that you like best. Turn you around a little bit. So you can plot points. You can just pick and choose, kind of, we call that plug and chug method. You plug a number in for x and see what you get for y, and then plot your x-y combinations you come up with. That's one method. Or specifically, and sometimes in your homework it will say plot by the intercepts. So there are x and y intercepts for a line, unless it's one of the special cases, and that might be different. But normally the x and y combo, it will graph some shape, some slope, and it will run through the x-axis as well as through the y-axis. So you'll have an x and y intercept. So that's a method we'll talk about. And then the third method is the slope y-intercept method. And I like this method actually. To me, it's a little bit faster, easier, especially if your line is already solved for y, rearranged in the form y equals. Anytime a linear equation, any of these examples we talked about over here, if I solve for y, the slope is going to show up in front of the x variable, the slope of the line. And then the last number is always the y-intercept. So you can just plot, go to your y-axis, dot that in. That's a known point on your line, just whatever that says. The slope, and again we'll talk about that more, is the rise over run from any known point on the line. So if you know this point, you'll plot that point, and then from there, rise over run, whatever this slope is, in front of your x, and then you've got your graph of your line. All right, so let's look at these examples here and practice this. So the first method I'm going to talk about is the point plotting method. And let's say we did x plus y equals 10 for our example. So there's a simple case of a line, not as many coefficients, just ones in front of the x and y's. So you could actually maybe just think about this and say, hey, what x and y combos solves this? Because that's really what you're doing when you make a t-table, is what can you plug in for x and y, so that it solves this equation. In this case, we want two numbers that add to equal 10. You might just think about it and say, hey, 5 and 5, if x is 5 and y is 5, hey, that's 10. 1 and 9, 2 and 8. So you could actually just think about that one. Now, that's not always true for all the equations, but it does make my point of what we're trying to do here is think up combinations of x and y that will make that a true statement. Those are points that we can plot on the line on the graph. And that's what graphing is. Graphing is taking our solutions to our equations, things that would make that true, x-y combinations, plotting them, drawing some sort of a picture, in this case a line. That's what a graph is, a picture of the solutions. So here's some sample solutions to x plus y equals 10. Okay, and then you can use graph paper or just sketch a graph. So the point 5, 5. That would be positive 5 on the x, 1, 2, 3, 4, 5, and then positive 5 on the y, dot. 1 and 9. Okay, I'm going to have to make my graph a little bit bigger. Over 1, x, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 on the y. And really, once I get 2 points, I could go ahead and connect my dots, but it's good to have a third just to verify you didn't make a little mistake. So over 2, up 8, and notice it's in line with those. And as it turns out, any combination of xy numbers that add to be 10, they line up perfectly. Just say one more. Say we do 3 and 7. Over 3, up 7. Should be right in line with those dots. Every solution actually to this lines up. There are infinite combinations that would solve that. They go on to negative infinity and positive infinity. The graph has arrows to show that there's no bounds to these solutions. You know, I could plug in negative numbers like negative 1 and positive 11 adds to be 10. So there's negative solutions as well, and way out there, positive solutions onto infinity both ways. These are just some sample ones to get our illustration going. All right, so let's do that again with one that we can't just snap off xy combos, like this 2x plus 3y equals 5. Now, I'm not going to be able just to tell you some numbers that you can double plus something you can triple, then they add to equal 5. As a matter of fact, I'm thinking it's going to have to either be some fractions are going to be in there, or maybe some negative numbers, because even if I times 2 times 1 and 3 times, oh, that actually does work, right? If x is 1 and y is 1, and there we have it, there is one that I could think of. But anyway, I won't be able to think of just a whole lot of those. It's not quite as easy. So what we normally do is we will think up numbers for x or for y, plug them in, and then solve for the other one. Typically, 0 is an easy number to work with, so you'll see a lot of t-tables that use 0, 1, and 2. So that's fine, and a lot of times that's all you need. We'll talk about that. When you plug in 0 for x, we plug in 0 for x, then we have 3y. We don't know what y is here. We're saying, I don't know the combo that works, so I'm going to equation solve. So 2 times 0, zeroes that out, so I just drop that out, and then I say 3y equals 5. All right, 3 times what's 5? Unfortunately, it's a fraction, which are a little harder to graph, but it's still a valid solution. We'll just have a little trouble getting it pinpointed exactly on a graph. And if you're using the MyLabs Plus program, it's just not calibrated to do the fractions in most cases, so that one's going to be hard to plot. So, but we can plot other points. You know, there's infinite solutions to a line, so let's just go on. Let's plug in that 1 for x. So we can start over, plugging in 1 for x, and saying, I wonder what y is when x is 1. So 2 times 1 is 2. And this is solvable. You know, we solve equations. We can minus the 2 from each side, get 3y equals 3. Then we can divide out the 3. Y is 1. And that's kind of what the one I could think through. If you plug in 1s for each of these, you can see that is true. That's what all your t-table solutions should be, things that make that true. So 1, 1, that's a nice one to plot. I wonder what happens when I plug in 2. And I could do this all day long. You can just keep plugging in numbers for x, see what you get for y. We can also do that from the y perspective, and I'll do the next one that way. That will be 4 plus 3y equals 5. Throw the 4 across the line, or minus 4 from both sides to equation solve. And y equals 1/3. Another nice solution, but a little hard to plot. So we'd like to get two that come out without fractions so that we can plot it on our graph, and so that will be a goal for you, especially since you're using the MyLabs Plus program. But just so I know, nothing's wrong with those answers. They're true solutions. They're just not easy to graph because of the fractions. So you might want to shop for another point, because like I said, we can do this all day long. Another thing we can do is plot from the y perspective. Plug in for y and see what we get for x. Say I plug in y is, let me try to think of something that will work out. 3. Let's plug in y is 3 and see what we get for x. So you can plug in on either side. So if I plug in for the y, I'm leaving the x there. Y is 3. So 2x plus 9 equals 5. Then I can minus 9 from both sides. 2x is negative 4. Then I can divide by 2. That one comes out even for me, so I like that. It's going to be easier to plot on my XY axis. All right, so that's the idea of plotting points, looking for points that solves that equation to then graph your line. Another point that a lot of time is requested in the second method we're going to see is plotting in the zeros. So we'd like to plug in y as 0 so we can know what the x-intercept is. So I'm going to plug in y equals 0. So that zeroes that out and just leaves 2x is 5. And then I can equation solve. It's one of those fractions again, but again, it's a valid point, just a little hard to plot. So just to note, the intercepts, and again, sometimes they request that you graph by the intercept method, would be doing the zeros of a t-table. So it's almost the same method, but it's more specific, saying I want to know where those critical values, where it crosses the x-axis, and that's called the, when you plug in y is 0, that's going to be your x-intercept. And then when you plug in x equals 0, you find your y-intercept, where it crosses the y-axis. So those, again, are critical points where it crosses the x and y axis. Sometimes they're requested specifically. If it just says plot points, graph the line, use any point you want. All right, let's see what this graph looks like. Okay, 0, 5/3. 5/3 note, and you could do this as a decimal, is about 1.7. So 0 and then up a little more than 1.5. I'll just have to guesstimate that. Over 1, up 1. Over 2 is up 1/3. Maybe about there. Let's see. Back 2 is up 3. And you can kind of see those points line up, don't they? This is 2.5. So over 2.5, 0. There's my x-intercept, because this is my x-axis. That's where it intercepts or crosses the x-axis. And then this way, there's my y-intercept, where it crosses my y-axis. And then connect your dots to show that there are infinite solutions. These are just some sample points, but the line is every little dot along that, that graph. Every little dot on that line is a solution as well. We just didn't represent it here in our sample points. There's infinite points you can plot. And then they go on and on both directions. All right, so that is plotting, plotting just generic points or by the intercepts. The third method is the y equals mx plus b method. So with that method, you solve your equation for y. Let me say this one, 5x minus 2y equals 6. If I was going to graph that line by this method, I would need to rearrange it by throwing the x term across the line, like so, and dividing by what's in front of the y variable. Solving for y gives you what's in front of the x, which a double negative makes that a positive. 6 over negative 2, negative 3. This is your slope. That is your y-intercept. So when you graph, you start at negative 3, then you rise over run from that point. So that's up 5 over 2. And then draw your line.